Hey everyone, and welcome to this explainer. So, have you ever actually stopped to think about how computer programs work under the hood? At their most basic level, programs just run top to bottom. They just execute this simple, rigid list of instructions. But today we're completely changing the game. We're going to give your code a brain so it can actually make its own decisions on the fly.
Think about it for a second. How does an app actually know if your password is correct? Or, how does a school's grading system automatically figure out if you passed or failed based on just a single number? It's not magic, right? It's all about decision-making logic. And that is exactly what we are going to build today.
To get to the bottom of this, we're unpacking the official Day 2 curriculum of Sir Inqilab Patel's rigorous Comp Sci Master Academy. This is pulled straight from the Cambridge A-Level Computer Science Summer Intensive, so we are learning the absolute gold standard fundamentals of Python programming here.
Okay, let's dive into this. The absolute foundation of everything we're talking about today is conditional statements. By definition, these are statements that allow your program to make decisions based on specific conditions. So instead of just blindly running code line by line, your program actually pauses, asks a question, and then acts based on the answer. It's really cool. Let's start with section 1, making simple decisions, the bouncer of your code. I like to think of your code as a bouncer at a VIP club, deciding who gets in based on a single rule. Here's exactly what that bouncer looks like in Python. We use an if statement. If age is greater than or equal to 18, and then right below it, an indented line that says print, you are an adult. If we translate this directly into everyday English, it enthusiastically says, if the age variable is greater than or equal to 18, then print, you are an adult. Now, if the age is, say, 17, the bouncer steps in. The condition is false, and that print statement is literally just ignored. No entry. But what happens when the bouncer turns someone away? They need something to say, right? That is where the else statement comes in. Take this exam grading example. If marks are greater than or equal to 50, print pass. Else, print fail. That else block, that's our bouncer's fallback response. It's the default action that automatically runs when the initial if condition turns out to be false. Moving right along to section 2, handling multiple choices, upgrading the bouncer. Sometimes a simple yes or no just isn't enough, like when you're calculating a student's exact letter grade. And this brilliantly illustrates how Python handles those multiple choices. We use the elif statement, which just stands for else if. It's this really elegant way to let the code check multiple conditions sequentially. First, it asks, is the grade 90 or above? If so, boom, A star. If not, it drops down to the elif. Okay, well, is it at least 80? If yes, A. It just keeps going down that chain until it either finds a true statement or it hits the final fallback else. All right, section 3, logic and comparison operators, writing the rules of the club. To make increasingly smarter decisions, our bouncer needs a very specific mathematical vocabulary. Let's briefly walk through this essential toolkit. Up at the top, we have our comparison operators. Notice that checking if something is equal to uses two equal signs side by side, while not equal uses an exclamation point followed by an equal sign. We've also got our standard greater than, less than, and those combinations. Then, down at the bottom, we have our logical operators, and, or, and not. These are incredibly powerful because they let us test the relationship between completely different variables at the exact same time. Here's a perfect example of that logical operator in action. If age is greater than or equal to 18 and citizen equals true. See what we're doing there? We're combining two completely distinct conditions. By using that and operator, we're basically telling the code that both of these independent conditions absolutely must be true for the code to execute. If you're 18 but that citizen variable is false, the print statement is not going to run. Let's move to and see how this builds in section 4. Conditions inside conditions, the double check also known as nested logic. This brings us right back around to answering our very first question about how apps securely check your password. A nested condition is, quite simply, a conditional statement written entirely inside another conditional statement. It's basically a secondary checkpoint. Let's walk through this two-step bouncer process visually. Step 1, the outer code checks if the username entered is admin. If it's not, it stops immediately. Denied. But if it is true, it moves to step 2, checking the inner condition. Is the password 1234? Only then do we hit step 3 and print login successful. The true beauty here is that the inner password check is completely protected by the outer username check's decision. So the crucial point is how we apply this logically to protect our systems, specifically through input validation. If we write if age is greater than 0 and age is less than 120, we're ensuring the user's input is actually realistic before the rest of the program even tries to use it. By nesting logic or using these logical operators, you are literally keeping bad data from breaking the whole program.
And finally, let's look at Section 5, Modern Structural Pattern Matching, the Python 3.10 upgrade. The CompSci Master Academy curriculum includes this as a really cool special pro tip. If you're using Python 3.10 or newer, you can shift from those messy blocks of logic to incredibly elegant structures. Now, what's really interesting about this slide is the contrast. On the left, we've got a traditional kind of long if-elif chain checking website status codes. I mean, it works, but it's a bit clunky. On the right, we use the match keyword to evaluate the status and case to test it against various values. It acts a lot like a switch statement in other languages, and it's just so much cleaner to read. And hey, note that little underscore at the very bottom? That acts as a wildcard. It seamlessly represents the default fallback case when absolutely no other pattern matches.
Well, we have definitely covered a lot of ground today. We've completely transformed basic top-to-bottom code by giving it a brain that can actually evaluate information and make intelligent decisions using conditionals. But I want to leave you with this final provocative thought. If conditionals are the brain of your code, what happens when we give that brain the power to repeat its decisions endlessly? Think about that for a bit, because that is exactly what we are going to be covering when we dive in to Day 3's topic, iteration and loops.